Everyone, my name is Dina Melendez. I am the Virtual Content Specialist for Multilingual Learners and English Language Learners for Mathematics grades 9 through 12. Today, we are going to be looking at Algebra 1, Day 31, graphing from the vertex form. So this is part of our Intro to Quadratic Functions unit, and we're going to be looking how to use Desmos as a tool, what are key words, okay, and what are key forms of quadratic functions. So it's important that in this lesson we understand what standard form is, what factored form is, what vertex form is, and how to compare and contrast all of these. So the first thing that we are going to look at, and this will be provided for you if you need it for your notes. If not, you can pause right here and take notes on this. We are looking at all our forms of quadratic functions. So we have the vertex form, which we are learning about this week. And we know that the vertex form gives us the vertex, right? We can see the vertex from the form, and it's right here, xy, or hk, or xy coordinate. You can find that in the vertex form. Now, the factored form gives us our roots, our solutions, our zeros, right? From this form, we can find what our solutions are. We find our roots. That's why R1, R2. We're finding our roots, solutions, zeros, x-intercepts. And it's usually expressed as x equals R1, x equals R2. These would be the numbers of the solutions. And in our standard form, our C represents our y-intercept. Our C is our y-intercept. So these are all things that once you understand these forms, you can quickly start and identify them. So for our compare and contrast, we are going to look at the exact same equation, but we're going to look at it in 3 different ways. So for compare and contrast, we're going to look at an example here, and you're going to be doing this throughout the lesson. So all of these 3 equations right here, they're the exact same one. They are all the equations. All of these are the equations of this graph right here. Now, they are all written in different forms. So I have vertex form, I have factored form, and I have standard form. And I want to make sure that you see and understand that these forms give us information that we need. So I see that my leading coefficient is 2, is a positive number. So that tells me that it's going to open up. It's going to open up, so it's going to have a minimum. The vertex, the turning point, is a minimum. Now, my vertex form gives me the vertex. And we know that then the vertex is -4, -2. Now, same exact equation, just written in factored form. It gives me my factors. I have that my factors are my roots, right? So I am able to find my roots with my factors. And I see that it'll be x equals -5 and x equals -3. And I have my roots right there. And then finally, my standard form, I have that the constant of the standard form is the y-intercept. And I see that that is also true because it crosses the graph in the y-axis at 30. So all of these forms will give you information, and you will be using them throughout this lesson. Feel free to copy this down or refer back to it at any point. Okay, so looking at the introduction lunch part of our lesson, it says compare and contrast. So we just saw that what we're going to be looking at when comparing and contrasting. Compare and contrast. Analyze 3 different forms used to define the function f. So we have the function f defined right here. It says what is similar, what is the same or close to the same about the forms. What is different? So these are observations you are going to make. There's no wrong or right answer. These are just you observing all these 3 forms. What is similar, what is different. Make sure to include which form best support you in identifying the x-intercept, the vertex, and the y-intercept. So remember those vocab words and remember the names of the form. The vertex form, what does it help me find? The factored form, what does it help me find? Standard form, what does that give me? Okay, and start making those relationships between all of the words and the different forms. Okay, so we are going to actually start off this explore together. Your teacher might actually have this explore given to you in a different way. She might give it to you through an activity in Desmos, through a Google form, through a Google slide. There's many ways to do this activity, but no matter the way that the activity is presented to you, the rationale behind it is going to be the same. So we're going to start working it together and see different ways that we can approach this activity to make sure that we are getting the correct answer. So it says, below are a set of graphs. So we have 1, 2, 3, 4, 5, 6 graphs. It says, match each equation to one of the graphs by writing the function and the letter of the matching graph in the table on the next slide. So if this is provided to you through this lesson, on the next slide, the continuing slide, you would write your answers. If this is given to you through a pair deck, you might be able to write your answer straight on this portion. So let's see, how do I approach this type of question? So there's different ways I can do this. There's different ways. I'm given 6 graphs, and then I am also given 6 equations, and I have to match them up. One way to approach this is that I can go to my graphs and I can identify the vertex in it. Why do I want to identify the vertex? Because I see that all of the equations here given to me are in vertex form. So they're all going to give me the vertex. They're all going to give me the vertex. So I can go ahead and identify the vertex of each one of my graphs. The other way I could do, I can identify the vertex of each and every one of my equations and determine whether it opens up or down. So let's do a few of these together. Okay, so I'm going to start doing the first thing I'm going to do is I'm going to identify the vertex. So the vertex, remember, it's always x before y, x before y, x, y. So I see that I'm going to count my x first. So my x is 4, and my y goes up to around 1. Okay, so I have found the vertex of the first one. Now I can actually go ahead and substitute it into my equation. Have that my equation here is the vertex form is x minus plus, right? So I left the space to substitute. H is the x value, so x minus 4 plus y is 1. X minus 4 plus y is 1. So now that I have this form, I can match it up to my different functions. Be mindful, this opens up. This opens up. That means that A is positive. A is a positive number. So I'm going to look at which one has -4 and 1. So I have -4 and +1, -4 and +1. So it can only be either J or Q. Now, we said that it opens up. That means A has to be positive. A here is negative. In this one, A is positive. So the correct response for this would be, this graph is the graph of Q of x. This is the graph of Q of x, of 2 times x minus 4 squared plus 1. Let's do another one. Let's do B. We're going to do this one in a different color. So I am going to find, actually I'm doing C, not B. We're doing C. I'm going to find the vertex. So I see that my vertex is, again, 4, comma, 1. 4, comma, 1. If you need to use this same equation, you can rewrite it here. You know it's going to be in the form of y equals x minus your h squared plus your k. Now, it's going to be x minus 4, because that's your x, 4 squared plus 1, which is your y, plus 1. Now, before I continue, I see that this opens down. This opens down. That means that my a is negative. That means that my a is negative. So a is a negative number. So now let me go ahead and check. It can't be q because we already determined that this one is q. So the only other one that fits is this one, and this one is negative. Therefore, it would open down. So then this graph is the graph of g of x equals negative x minus 4 squared plus 1. Okay, so the other way we could have done this, I'm going to now change colors. And instead of looking at the graph, I'm going to look at the equation. I've already used G. I already used Q. So let me look at the first one. Let me look at F. So I have here that according to this, my vertex is going to have to be 1, comma 4. It's going to have to be 1, comma 4. And A is positive, so it's going to open up. So knowing this, I'm going to only look at graphs that are opening up. So that can automatically at least eliminate one of them. It's not going to be D, because D opens down and I need it to open up. And then it has my vertex. It has my vertex at 1, 4. So it is in the positive quadrant, right? So this is in the negative, negative. This one is in the negative, negative. So these two are eliminated because the vertex falls in the negative, negative quadrant. Now, what about this one? It is in the positive, positive, but I'm going to make sure that it actually fits. So I have 1 on x, 4 on y. So I have that my vertex is 1, 4. And I also have that it opens up. Therefore, this one is the function of f of x equals x minus 1 squared plus 4. Try out the other 3 with the rest of the equations so you're able to match them up. After you finish the matching, you are going to be asked to explain. You're going to be asked to explain how you know they belong together. So take all those observations you made and write an explanation of how you are able to tell that the different graphs belong together. After you finish your explanation, you can go ahead and finish your summarize, and you're going to be towards the end of the lesson. I hope this was a good lesson, and I'll see you in the next video.